All right, so in our lab today, we're going to be burning some different substances and looking at the characteristic flame color that we see. So it's going to change the flame of our Bunsen burner into some different fun colors. And we're going to use this information to identify an unknown metal. So I'm going to do the procedure, but I just want to make sure that you understand what we're doing because it'll help you answer some of the questions afterwards and finish up our lab. So what you're going to see me do in a minute when I get over into the lab is you're going to see that I'm going to pull some wood splints, just basically some sticks that have been soaking in some different chemicals here. And then I'll show you and tell you which one is which as we're doing it. But I've just dissolved this stuff in some water and then put the sticks in there so they can soak up that water and that chemical. And then what we're going to be doing is basically holding that stick into the hottest part of the flame and watching it change the color of the flame as it's burning. What's happening is the water is going to evaporate and take some of that chemical into the fire with it. So the stick isn't what's actually burning, it's just that chemical that's in the water. The stick is just how we get it into the fire. So you're going to see the fire and it's going to have its own color. And as we stick the sticks into it, it's going to add a color or kind of change that color. And that change is what we're going to be looking for. So a lot of these are going to have some kind of blue background because that's the original color of the flame. But what we're going to be observing is the color the flame turns when we add these different substances to it. So that's really all you're going to need to do as you're watching this video is write down what color you think these flames are. And in general, it's just focus on the color of light, red, orange, yellow, green, blue, purple. But I don't want just a single word there. I need at least one, I said 2 to 3 words, one descriptor on that color. Because some of these are going to look fairly similar. And I know especially with a recorded video, they might look really similar. But do your best, even if you have to go back and kind of click through to compare one to the other. One might be brighter or lighter, or might be mixed with another color, kind of an orangish red or a bluish purple. Add at least one kind of clarifying word to that color that you're writing down. So each of these spaces here should have at least 2 words in it describing the color of the flame that we are observing. Now I'm going to start by doing these 6 elements in this order, and then I'm going to give you an unknown. And I'll go ahead and tell you that the unknown that I'm going to be burning for you today is going to be unknown F. So you can go ahead and fill that into your data table there, and then just observe its flame color just like everything else. And all I've done for that unknown is pour a little bit of one of these other 6 chemicals into a beaker that isn't labeled with the chemical name on it. So the students in class got a random beaker with a letter on it, and they just had to burn it and compare that color of light to the other colors they had already seen in order to identify what that unknown is. So you're going to be doing the same thing here. You just don't get to do the fun burning part. But you know you can always ask me to burn things in class if we got the time. I would love to let you experience this in class. I'll talk about more of this analysis stuff after we've gone and burned some chemicals. So here I've got everything set up for our lab. We're going to be first seeing our calcium, copper, lithium, and sodium, barium, and strontium. And then of course our unknown F. They've all got sticks soaking in these liquids. They're a little bit worse for wear. Some of them got a little bit burned, but I should be able to handle doing this without burning the sticks too bad. Let's get you set up here where you'll be able to see that Bunsen burner flame. And I'm going to turn out the lights to get some better contrast. All right, let's see our calcium and how it changes the color of our Bunsen burner flame. Takes a second. There we go, starting to get some of that. that's better. Notice my stick is not what's burning, so that's not where that color is coming from. It's getting pretty close. That was calcium. Now here we have copper. And this one is lithium. And here we've got our sodium. And then we have our barium. And then strontium. Now this is our unknown, unknown F. Okay, so those are all of our colors that we need to observe. Make sure you've got 2-word observations for each of those, 2 descriptive words about that color. And now let's go and talk about what we need to do to finish up this lab and do those analysis, calculations, and questions. All right, so the first thing that you need to do in our analysis of this flame test lab is to decide which element was your unknown. So, which color of the other elements most closely matched the color of the unknown that you saw. So write the symbol or the name of the element here. Make sure that you wrote F as your unknown in your table, otherwise I can't give you points for identifying it correctly. And what I need you to do next is a little bit of research. We're going to go online and look for that element, the unknown element that you chose here, and find their emission spectrum in order to be able to look at some more specific wavelengths of light that's coming out, more than just the general color that we saw. If you haven't watched your podcast about this topic yet, the colors we're seeing are a combination of colors, and they make these lines in the spectrum where we have all of these different colors of blue here coming out of our hydrogen, and then one really clear red line. So this is hydrogen. This is not one of your possible elements. But I wanted you to make sure that you knew what you were looking for with that emission spectrum. And all I literally did was go into Google and type in hydrogen emission spectrum, and then went to image search. And what's really important is that we choose one where we can see the colored lines, the bands there for your element, not hydrogen, and we have some numbers to put with it. So I have these numbers here. So we need lines, colors, and numbers overall that match your element's emission spectrum. And there's probably going to be several out there, and lots of them here have like lines and colors, but this one doesn't have any numbers, so this wouldn't work for you. If it does have more than one element in it, that's fine, because you will have told me which specific element you were looking for. You don't have to do anything fancy with it. But you might have two different looking spectrums for the same element. You'll notice this has all those blue lines and that one red. This first row hydrogen emission spectrum here is the same, kind of a different version of the same thing. We got all those purple and blue lines and that one red. This is a fingerprint that we can use to identify our element, but that's more podcast stuff. I want to help you finish out the lab, but this is important, and I'm going to go ahead and copy this one. And we're going to paste that emission spectrum, you choose your own, in here. And we don't really need it to take up much space. We just need to have it so that we have these lines to reference. And we're going to use some of these real wavelengths and numbers from that emission spectrum in order to do some calculations. So what we need to do next is actually to choose a couple of lines. So we're going to choose two lines. The first line's information and calculations is going to go in this first column. The second one will go in the second column. So I'm going to go ahead and choose that red line there. So I'm going to write its color here. And then I'm going to take the number that goes with that line. And I know that there might be different wavelength units. This one was angstroms, whatever that is. I know that y'all aren't familiar with that. And it's got this 6562.8 number. If you looked at the other version of this emission spectrum for hydrogen, it has a slightly different number. It says 656.3, and they're basically the same numbers. It's just one has more sig figs than the other, and their decimals are in kind of different places. So I don't want to have to kind of get picky about what units your picture has, because these took enough time probably for you to find a good one as it is. So I'm going to help you take the information from whatever units you have in your picture. We just need those numbers. We're going to change the form of those numbers. You're just going to take the first three digits. So for me, that would be 656. And you're going to replace in either form of this number. We're going to make that our wavelength, either in the times 10 version of that number, or if you'd prefer to write it out with an E. Just take the first three numbers and make it blank, point, blank, blank. So I'm going to make mine 6.56. And even if I had been using the other emission spectrum, that was 656.3, I would make that 6.56. Just take the first three numbers and make it have the decimal after that first number. And that has effectively changed whatever your wavelength is into meters, because we need to have those meters units. So if you and I have chosen to write our number out this way, you can just delete that way. It's really a personal preference which way you like to look at these numbers. So I'm going to choose this other blue line here. Its first three numbers are 486. And just for grins, I'm going to do this other way. Doesn't matter which way you do them. Personal choice. Just want you each to see that you can take either version of the number and just replace those first three digits with your three digits from your spectrum. And then we're technically done with the spectrum. We're going to leave it there, and I got points for your lab for having done that research and put that in there. But now these are going to be our given, the numbers that we use. These are our wavelengths, and we're going to use that to calculate energy and calculate frequency. Now, notice I didn't have to put any units here on these numbers because that's already defined over here in the table. So all I need are numbers here. We are going to have to do a little work. Your calculator is probably going to do most of the work, but I need to see that work documented here. So I'm going to kind of walk you through how I would do these calculations just to make sure you understand what your options are. And I'm just going to type out my equations and everything right here in this space, just like I would type it out in my calculator. If you'd prefer to do this work on a piece of paper, feel free to do it on a piece of paper. Just take a picture of that piece of paper and insert that picture here instead of your typed out work. One way or the other, I need to see what you're putting in that calculator physically here in this document. So I'm going to write out two equations that are going to help us calculate our energy and our frequency. Alright, these are the two equations that I think are going to be the most useful for you in your calculations. Now, I did do a little special formatting here because that's the way the equation looks like in our packet and on our reference sheet, but you could just as easily say E is equal to HC divided by that lambda symbol. And you don't have to write out the original equations, but you can write out the numbers as you're showing the work just like this as well. I just wanted you to understand better what my plan was and where my equations and numbers were coming from. So this is our equation to calculate energy if we have wavelength, which is exactly what we've got and what we want to do. So all we should have to do, and this is the part I would need to see, is at least you plugging in the numbers to this equation. And you can do it just all in one line, just like this. Say E is equal to H, which is 6.63, E negative 34. I really do like my E version of things, but you can just as easily say times 10 raised to the negative 34, just like you would in your calculator. You don't even have to try and struggle to make this into an exponent. Just use that same symbol that we use in our calculator to make it an exponent. Just make it work for you. I'm going to use my E version. And then we have that times our C, 3.00E8. And then I would be dividing by my wavelength, which here is 6.56 times 10 to the negative 7. So if this is the equation I'm doing, then this is the way I would type it out in my calculator, and I just need to see you type it out that way in your document. Then you can put that in your calculator, find the answer, and that'll go here. And then technically you could use that answer to find your frequency, or you could use this equation to find your frequency. You're just going to have to rearrange it a little bit to actually solve for frequency so that you can plug in your wavelength and your C in order to calculate that frequency directly from this number. But you can type it out just like this, or you can start going in and getting some fancy equations to make it look all fancy. But I just need to see your work for both of the calculations for each of your lines. So do this for your first line, and then do the same type of thing for your second line, and show all 4 of your calculations here. After you've done that and filled in your table and shown your work, we have a couple of just general analysis questions, and they're probably going to end up going on to that next page once you get done filling all of this in. Just going to delete that to clear up my space. And this is just a fill-in-the-blank question, so these are our blanks, and these are the words that you're going to be filling into them. And they can be used multiple times. They kind of have to be if we have 5 blanks and only 3 words. And then qualitative versus quantitative, again, that was a really old idea we had in our Unit 1 topic, but I think you can handle it again. Just make sure you explain why that was either or. And then question 3 throws people off sometimes. So to help you out with that, remember when I showed you the materials list? The materials we have and what was on the side of our beaker was calcium chloride, copper chloride, lithium chloride, barium chloride. All of these have an element, metal, that we were focused on and observing in our data table, and then this non-metal that was not written in the data table. And what question 3 is saying is that we made an assumption here that the color was coming from the metal and not the non-metal. So what evidence is there? What did you see in the lab that would be proof? If someone was like, wait, but that red color could have come from the chlorine. How did you know that it came from the calcium instead? Then you saw something in the lab that would prove to you that that color was coming from the metal and not the non-metal. So look at that materials list, look at your observations, and I think you can kind of put it together about what is happening there and why. And then don't overthink it. It's right there in front of you. You don't have to do any extra research or Googling of anything. You can figure out the reasoning why straight from this lab with what's written on this paper. And then do your best to figure out another way to test and prove that that color comes from the metal ion, something we could change about our current experiment that would reinforce and prove to someone, if they didn't believe us, that the color came from the metal. And these last two questions are really just kind of analysis questions applying what we've done. You will need to go back and look at your observations from the lab in order to predict what metal ion you think would cause that bright yellow flame. And then kind of the opposite of that, I tell you that these two elements were named based on their flame color, and told you cesium's named after this, rubidium's named after that. What colors do you think these make and their flame colors? So just use your best judgment there. Just make sure that you address both of these elements here specifically. Tell me what colors they would be. Let me know if you have any other questions. Hopefully this helped, and you understand the lab and can get that finished up and turned in.